Hello everyone and welcome to SQL Friday. This is SQL Friday number, I just have to go to the next slide to see. I think it's number 16. Yeah, it is. Perfect. So it's been a blast for the past 15 ones. I think today will be as well. Our star for today is Eitan Blumin.
Hello.
You might have heard his name from SQL Server Radio. He's one of the co-hosts together with Guy Glancer, who was here just the other week. Eitan is going to talk about how to HADR or HADR your SQL jobs, which is it's an important topic and it's easy to forget about it. So I'm super interested in this. I'm not going to do much of an introduction more than that. I'll leave it to you. So just take over the screen share and introduce yourself whenever you're ready.
Sure. Okay. All right. So thank you for joining. My name is Eitan Blumin from Madeira Data Solutions in Israel. As Magnus said, I'm also co-hosting the SQL Server Radio podcast together with Guy Glancer, also from Madeira Data Solutions in Israel. I also have a blog on eitanblumin.com. I have a Twitter account and a few other accounts in social networks. I'm a certified Microsoft associate and expert in SQL Server, and I recently also became a Microsoft Data Platform MVP. So congratulations to me. So let's dive in on today's topic. So today's topic talks about something like the following scenario. We have two or more SQL Server instances with some kind of high availability solution set up between them, be it always on availability groups or database mirroring. And besides the database or databases themselves that are taken care of automatically as part of said solution, we also naturally have scheduled SQL Server jobs. But there is no comparative solution, high availability solutions for jobs, as in what would happen to a job in the event of a failover, when the database roles are changed suddenly. One job might be able to run on regardless of whether the relevant database is primary or not, or secondary or principal or mirror, but other jobs may fail due to this failover. And also, I'm not going to focus too much about the actually most common scenario, which is very unfortunate, where people are not addressing this issue at all. Like usually what I tend to see is that there is one, let's call it designated primary instance, where all the jobs are set up properly and they have the proper schedule and their proper definitions, and they are assumed to run there always. And in the event of a failover, then these jobs tend to start failing. And on the secondary replica, which is now the new primary, we tend to find that the same jobs are not configured. They're not configured in the same way. So there are significant differences in the environment. The solution, the environment, the database environment does not function the same way before and after a failover. So we have missing jobs, we have perhaps different jobs with differing settings, different steps maybe, different schedules maybe, but this is also a wider topic beyond jobs, because we also have other server level objects that are also not synchronized automatically as part of a high availability solution, such as alerts, operators, maintenance plans, database mail settings, and so on and so forth, And there's also, even beyond the scope of SQL Server itself, stuff like file shares, permissions, accounts, Windows accounts, or something like that. So this is a much larger topic, actually, but today I'm going to focus specifically on the scheduled jobs, because this is which is something that could be a bit more under our control as DBAs, as database administrators, and it is also something that is more common in terms of we have to make this the same, like across all the replicas. All the jobs at least have to be the same, and they need to work wherever they must work, depending on the role of the database. So, as I said, usually what we tend to find is that there are no solutions for this. I mean, there are environments without a built-in solution for this. So at best, they could have like the same jobs configured on both instances, the primary and secondary. And they will be running all the time with the same schedules, perhaps. But on the secondary, until a failover occurs, these jobs would fail all the time. And after a failover, they would start failing on the primary instance. So there are a few problems with this scenario. So first of all, if you have some kind of automated monitoring and alerting platform, then this would cause lots of noise for you, because it would become impractical to monitor for failed jobs, because you would always have failed jobs somewhere. So that's really bad. And also, they would all of these executions, which would actually not mean anything, they would also fill up your MSDB job history tables. So and it will also be difficult to troubleshoot your job history execution histories, and see what happened when and where and why. Sorry, because most of these executions would be like they will be meaningless, because they didn't fail because there was some kind of actual problem. They failed because the relevant database was with the incorrect role. One common solution to that I tend to see is where DBAs add some kind of validation step, some kind of prerequisite initial step to each of these jobs. And what this step would do is it would check whether the relevant database is the primary, has the primary role. If it doesn't, then it raises an error which causes the step to fail. And then when the step fails, it's simply configured to quit the job with success. And if the step doesn't fail, then it moves on to the next step. And then the actual job starts running. So that's okay, that could work, but there are also some problems with this. First of all, it would mean that you would have to manually add, or somehow add these steps to each and every job, at least the relevant jobs. So that's a lot of overhead in terms of DBA work. And every time there's like a job is, perhaps it's dropped or updated, or a new job is created, we need to make sure that this preliminary validation step also exists there and is properly configured. Also, in terms of the execution history of these jobs, we also run into the same problem as before, where the MSDB job execution history is filled up with nonsense, basically data that is not interesting to us. We don't really need to see all of these pseudo failures, because it hinders our ability to troubleshoot actual failures. It's not interesting to us as DBAs to see that a job failed, but it actually didn't fail, but it only did so because the role was incorrect. As DBAs that want to troubleshoot issues with jobs, we would rather prefer to see actual executions, meaningful executions in the job history, and then see what succeeded, what didn't, and why. So the best solution that I found was something like this. We would have one more, let's call it master control job, whose job would be to control all the other jobs. That came up a bit redundant. But anyway, the idea is that this job would be responsible for either disabling or enabling the jobs, the other actual jobs, based on a database role, whether it's the primary or secondary. And then when the instance is secondary, this job wouldn't even run at all. It would be disabled. So, and then it solves all of our problems basically, because we don't have junk data in our job history, and this job, this master control job, would be responsible for basically failing over the jobs by playing with the enable flag. The implementation of such a master control job would look something like this. If the current server is primary, then enable all jobs. Otherwise, disable all jobs. But wait a second. Current server is a bit confusing here, because what am I talking about? Am I talking about the instance, the SQL Server instance? Am I talking about a certain availability group or a database mirroring session? Maybe a certain particular database? Which one? I need to know what am I even checking? So let's assume that we know which database to check, because these availability groups and database monitoring, their core entity that is being controlled is a database. So a database role, which is also what a database is also where these jobs are executed. So I could assume that a database is like the central piece that I need to check. I need to check the role of a certain database or databases maybe. Let's assume for now that we know which database to check for its role. Okay. So if the database role is primary, then enable all jobs and otherwise disable all jobs. Do I really want to do that for all jobs? Probably not, because I might have also unrelated jobs. So maybe I need to control a specific list of jobs. But then I need to maintain that list of jobs. Maybe I need to query jobs based on their names or based on their category. Or maybe I could utilize their inherent database context, which is configured at the step level. So there are certain ways to approach this. So, and the best way might be to, in my opinion, to use the database context of T-SQL steps and use that in order to identify which jobs are relevant to which database. So let's assume that I know the database that I want to check, and I know which jobs are relevant to this database. So I could have something like the following algorithm. But do I really want to make sure to do this logic based on whether the database role is primary? What about jobs that need to be executed actually on secondary role instances, databases? For example, what if I have some kind of like a data warehouse query that only aggregates data, so it only needs to read data from the main database and maybe save it someplace else, and maybe it's something that is very stressful, very heavy, cause lots of local stress, and I wouldn't want that stress to happen on my primary replica, because I have the other online transactional stress over there, and I would want to mix also the data warehouse aggregations on top of it. So I decide to have like the primary with the online transactions, and the secondary, in this case, it's only possible secondary readable, and as in always on availability groups. So if I have a readable secondary, I can use that to query data, and the database, it's enough for the database to be read only. Okay. What if I have jobs that should run either way, like regardless of whether the database role is primary or secondary? Maybe it's some kind of maintenance job or something else. I don't know. There could be all kinds of possible scenarios. What if I have jobs that I don't want them to run ever? What if I manually disable the job, and I don't actually want this master control job to suddenly automatically turn on these jobs for me without me asking? So those are all possible scenarios. Okay, so what we're going to do is we're going to construct a bit more complex algorithm, which would be more, let's call it versatile for our purpose here. So we check in either a job or a specific step or a category of jobs whose name is something. Let's say begins with something, includes something, equals something, doesn't matter. For each such job or set of jobs, I'm checking their relevant database role based on the, let's assume at least, based on the job step database context. Okay, so if the database context of these job or jobs is either primary or secondary or either, which is something that I could configure, then enable or disable. And I would have a set of such rules, let's call it that, which I could maintain as some kind of server level configuration. And this master control job would use this set of rules to manipulate automatically all of the relevant jobs. So I think that's a good solution. We're going to go with that. But wait a second. There's also a bit of a problem with the master control job itself, specifically in terms of its scheduling. When should I schedule this master control job to run? This is also a job, and it is to be scheduled, obviously. So what I would want is for this job to run at least as often as my most recurring actual job that I want to control. For example, if I have a real actual job that runs every, let's say, 10 minutes, then this master control job needs to run at least every 10 minutes, if not more often. So that if between different executions of the actual job, let's say there's the 10-minute interval job it executed, then like let's say after 5 minutes there was a failover. So after the next 5 minutes, they would be the next execution of this job. And I need this master control job to run before that, so that I wouldn't have like so the actual job wouldn't fail just because the role was incorrect. But there is a better solution using a built-in mechanism of SQL Server called alerts. Alerts are actually event-based mechanisms that you can use to execute jobs. And they are event-based, as in whenever a server-level event is triggered, such as an always-on role change or database mirroring state change, when either some kind of database changes from primary to secondary, from resolving to principal, mirror, whatever. Only then I would immediately want this master control job to run and make sure that everything is as it should be. So I would rather have this master control job to run upon the SQL Server agent startup, so that maybe if I have some kind of failure, a hard failure and the server was shut down, then it comes back up again. I want to make sure that given the new situation that the server is in, then the jobs have the correct status. And also, just in case, you know what, let's also schedule it, just in case, because I know, you never know. Sometimes events could be missed. I don't know, I never looked into it. But it's something that couldn't hurt. It doesn't have to be, obviously, as often as your most recurring job, but it could be something like once an hour, once every 2 hours, you know, something minimal, okay, just in case. And so this would solve the issue we saw before, where we have lots of junk in the execution history of the master control job. It will be very beneficial, I would say, that to see in the history of the master control job only like actual meaningful executions. Okay, so you know what? That sounds like a plan. Sounds like we have a really good solution that we can use. But wait, we need to implement this. That sounds a bit complicated, you know. We went through quite a bit of stuff, and it sounds like a lot of work. So, did I show this to you just, you know, as an idea that now you need to go ahead and implement yourself? No, you don't, because I already did it for you. And this solution is available for free on our GitHub, and there's also a shortened link on the screen. And this solution is available on the Mardera Data Solutions GitHub account, as you can see on the screen, all the links. So this is available to you. We have a version for the always-on availability groups and a version for database mirroring. And there's also a classic version which is based on an older, more basic algorithm, which is dependent on a specific list of jobs rather than something more robust and automated like what I just showed you. And I'm gonna go ahead and show you the basics of how to use this solution. So the solution basically is one single T-SQL script that creates the master control job and the corresponding alert. And it would also have these 3 parameters at the top of the script, which say what I want to have, what name I want to give to the master control job, what name I want to give to the alert, and then there's all kind of configurations, special configurations for the special use cases. So let's assume that you don't give this a value to the special configurations parameter. There is a default behavior. The default behavior says it goes something like this. Let's assume that we have a job with multiple steps. Each step is executed on a different database. So the default behavior says, check the current role of each of these database contexts for all the T-SQL steps. And if at least one step belongs to a database which is, let's say, primary, and therefore should be enabled, if at least one such step exists, regardless of all the other steps, then the whole job should be enabled. I could think about like possible edge cases where one single job is executing has different steps, where each step has a different context of database context, and each database belongs to, let's say, a different availability group. And then one database might be primary, the other might be secondary, and we would have like this sort of mess. So I figured that this behavior should still be the best case, at least because this is really like an edge case. Like, it's quite rare to see such a scenario, and I would hope that if there is such a scenario, that you would have to also implement, let's say, something like an if at the start of your steps, your T-SQL steps, that would make sure that this database, the relevant database, has the correct role before proceeding with the rest of the logic. Okay, so let's see what we can do with all of the other special use cases that are not what I just showed you. So what I can do, play around with the behavior of this master control job. What I can do is configure a set of rules. Each rule I call an item, and there are 3 types. I can have a rule of type job, rule of type category, and rule of type step. Each such rule would also have an attribute called enable when, in order to tell the relevant job when should it be enabled. So in this example, I have an item of type job. Says that it should be enabled when the role is secondary, and the content of this item is contoso and wildcard. So this is, as you could probably guess, this is used in a like expression, so you could use also like compatible wildcards here. So basically this means that all jobs whose name begins with contoso, they should be enabled only when the relevant database context has the secondary role. Another example is if I want to say all jobs that belong to category database maintenance, they should be enabled regardless of the role of the relevant database context. So that means so that is represented by enable when equals both. I have a rule for a step whose name is generate BI report. So that means all jobs that contain a step with the name generate BI report, these steps and consequently the jobs should be enabled when the role is secondary. And also I have, let's say, a category for SQL Sentry jobs that I actually wouldn't want to control. I wouldn't want to change based on the database role. I want to ignore them as part of. More precisely, I want the master control job to ignore these. So, for example, SQL Sentry, when you configure a monitored target for SQL Sentry, it creates 2 jobs for you. One is enabled and one is disabled, and that's how it should be. So I actually wouldn't want to touch that because that's the intended behavior. So this is one way of taking care of that, to tell the master control job to basically ignore these jobs. What about jobs that actually don't have a database context? Database context is something that is relevant to T-SQL steps, but what if I have other types of steps such as SSIS, SQL Server Integration Services, or maybe PowerShell or Command Exec? They don't have database context. So I can create a rule that would still check these jobs, and I would tell the rule which database I want to check, instead of the rule trying to look for the database context of these jobs. So this is a way to define rules for jobs without a database context, but it's also a way to define a rule for jobs that do have a database context, but I want to override it. Okay, so let's say, for example, for whatever reason, the database context of your job is master, but its actual logic affects a certain database. So I want to tell the job which database it should check. And also I have a rule that says all jobs that belong to category called, let's say, disabled jobs, enable when, never. So this is a way for the master control job to enforce a set of jobs to always be actually disabled. So you could say that this is like the opposite of enable when both. Not exactly when you consider how does enable when ignore factor into this, but I hope you get the idea. So this is like a way for you to enforce certain jobs to always be disabled, regardless of the database role. So this is the solution that I have for you. It exists, like I said, as an open source, free open source solution. Now it's the time for some questions. This is a pause, okay? I have some more stuff I want to talk about after this. But if there are any questions, now is a good time to bring it up.
Yeah, I don't see questions in the chat, so if anyone has any questions, just please type them and I will relay them to Eitan.
Okay, so let's give it a minute.
I see Roni is writing. I have one.
Let's hear it.
Regarding CDC jobs.
CDC
I don't know if there
jobs.
is a follow-up for this. But I guess
I don't actually have much experience with CDC, but I hope that like you could. Okay. Like there's this special configuration parameter that you could use to implement whatever logic that you deem correct for the relevant jobs. Do you want them to be ignored? Do you want them to always be enabled? So whatever it is, it's up to you. Any other questions?
he's still typing. So we have CDC configuration on a DB that is part of an AG, and in case there is a failover, and we always need to sort something with it. This kind of resembles, you know, with CDC there's a log reader agent, so I guess it resembles transactional replication or something as well. I wonder if that will help.
I would guess that CDC is something that should be relevant only to the primary replica, because it's used to log changes, right? In a database,
Yeah.
and you have only one primary replica, so I guess that's where they should be enabled. So I hope that answers the question.
I mean, I would assume the same, and I see Roni is sending with a yes, so I think that's probably answered the question. I saw Colin was writing too. I don't know if there is a question coming up, but just see that someone is typing. I don't know what. It could be worth a test, Roni says.
Sure, go for it.
And let's see if Colin Walker comes up with a question. He's still typing.
That's a big question, is it?
Where is the config held?
Where is the config held?
Yeah. So
well,
where do you put the config?
The open solution, the open source solution is basically a single T-SQL script. These configurations are right at the top. Okay.
Okay.
The rest of the code of the script is to create the master control job with the name that you gave it, and the relevant alert, connect between the two, and these special configurations, this thing, is also injected into the master control job itself.
Okay.
So you either set this up at the beginning, like at first before you run the whole script, or you could manually change it after the master control job already exists. The same parameter also exists at the top of the T-SQL script of the job.
Mm. So I guess if you want to make a change, I would probably the ideal would be to have like a CI/CD pipeline that pushes it out and recreates the job with the changes that you made to it, I guess. So,
yeah, if you have such a pipeline, yeah, that would be good.
Yeah. Cool. Well, there is no more questions in the chat right now. So
let's go ahead and continue. So one common issue related to SQL Server jobs and HADR is the notion where there could be a difference between these jobs. Like, what if what if some jobs are incorrectly configured, like there's some kind of difference, or maybe I have missing jobs either on the primary or on the secondary, and I want to have some kind of solution that would alert me about such a scenario. So This is something that I developed for an actual use case, actual customer, real-world use case. And this is called compare AG replica jobs. This is a PowerShell commandlet. It's also open source, as you can see, available in our GitHub. So what it does is generate a report for you that compares between the jobs of a given master server, master instance, and a target instance. So we could have, let's say, give me a second to find the syntax here. Okay, so this is the syntax of the commandlet. You give it the computer name. The computer name is like, let's say, your entry point. Okay, this is enough for the commandlet to work. What it does is connect to the server that you specify in computer name, and this automatically discover which availability groups are in that server, which databases are in each availability group, and which jobs are dependent on these databases. And then what it does is it takes this list of jobs per each availability group and compares this list of jobs against the same jobs in each replica. And then it generates this report for you that says wherever there is the difference, then you would have this kind of indicator. When the same job exists on both replicas, but it's different. And this indicator means that the job exists on the target, but not on the master server. And the other way, this indicator means that the job exists on the master, but not on the target. So let's say, and in addition to all of this, we also have a change script generated for you that addresses these differences. So if the same job exists on the target, but it's different, then it drops the job on the target and creates it based on definition at the master. If it exists only at the target but not at the master, then it generates a drop command, just a drop command for the job. And if it's missing from the target, then it generates the create command for the job. And all you gotta do then is take this change script and run it on the target server in order to match it with the master server. Now, when I say master and target server, I basically mean primary and secondary, okay? I assume that the current primary server is the master server in terms of like the jobs. Like it's your source of truth. And this sort of report is generated per each availability group and each replica, sorry. So you can also see that we have email-related parameters here, this and also this, that you can use to send this report by email, in the same way that as you see it here. And or you could also use this parameter called output folder, where it would generate this HTML report and simply save it there together with the relevant change scripts. You could also use this parameter called job categories in order, if you want to filter the job based on one or more categories. This is an array, so you can have one or more. And that's about it. So this is obviously not as robust as the master control job that I showed you, but it was good enough for the actual use case, and that there wasn't really a need, at least meanwhile, for now, for something more robust than that. But I think it's a good start. That's also available for you for free. Also, speaking of free tools, I cannot go along without mentioning DBA tools, speaking of PowerShell. So there's DBA tools. They have lots of commandlets, relevant commandlets that you can use in order to synchronize objects, including server-level objects, between different instances. And specifically, you have this new commandlet It was created, I think, relatively recently. What it does is, as its name implies, it synchronizes all the server level objects in an availability group. So that includes the jobs, the logins, the database mail settings, what else? Linked servers, and categories, alerts, operators, proxies, all of those cool things. So that is very useful if you want to make sure that your instances are aligned in terms of the server level objects. How are we on time? Pretty good. Okay. So I want to talk about something which is a bit old and is little known. There is a SQL Server feature, built-in feature called MS66, also known as multi-server environment something. So the idea is that you have a master server in a multi-server environment, and you have multiple target servers. And this master server would have a list of jobs, SQL Server Agent jobs, that it would automatically, periodically synchronize to all of the target servers. That sounds awesome, right? Like it could be like a really good solution in an availability group or database mirroring environment when if we could set up like a specify, okay, this primary server is also our master in terms of the jobs, so it will also automatically synchronize the jobs to its secondary or mirror server. That could be really good, right? Unfortunately, there are very big and glaring problems with this feature. The biggest problem is that a server which is designated as a master server in a multi-server environment cannot also execute these same jobs. Because in order to execute these jobs, it would have to be also a target server. And there is an error in SQL Server where when you try to set a master server as also a target server, that says a master server cannot also be a target server. So that's a very big problem, and basically renders the whole feature completely useless, if you ask me, because it means that the only way for us to use it is if we set up a dedicated server that its whole purpose is to be a master server that synchronizes jobs to other target servers. I mean, that could be reasonable if I could set it up as an Express Edition server or something like that. But there are limitations to the MS66 feature, which say that you can only set it up on either standard or enterprise editions. So just to set up this dedicated master server that all I want to do is for it to do is to synchronize jobs, I need to pay a lot of money in terms of licensing. And that's a real shame. So as you can see on screen, I have a feature request that I submitted to Azure Feedback precisely for this purpose. So there are a few things that I request in this feature request. One is to, let's say, remove this limitation in order to allow a master server to also be a target server, and then I could set it up and it would be really useful in an HADR environment. I also, in the same feature request, I request to expand this feature of synchronizing some kind of server level object between servers, to expand it to other server level objects such as operators, alerts, logins, server triggers, what else? Linked servers, and whatever it is. So if we could get this kind of solution already built in for Microsoft, that could be really awesome. So it's up to you guys to help me out and vote on this feature request. And who knows, maybe share it around, and who knows, maybe someone at Microsoft product team will notice and do something, move it forward. So I think that's about it. That concludes my presentation for today. And if you have any more questions, now is the time.
Cool. I see Abraham is going to vote for, so you have a 25% increase. It's good. If the 3 was your actual vote. So that's awesome. I think there is a lot of love to put into the MSX TSX functionality, regardless if it's HADR or something else, because I found it quite buggy, to be honest.
Yeah, I know. It's a really old feature. I think it exists since at least 2005, SQL Server 2005.
Yeah, so I mean, it's time to make it work, right?
Yeah, and make it better.
Yeah. We used it in a place where we had something like 400 or 500 instances, and it's, I mean, it usually worked, but that wasn't kind of good enough for it to almost always work. We needed it to actually to rely on it, because we wanted it to run the backups and such. And
yeah, that's important.
yeah, so if we changed scheduling for backups, we actually wanted the scheduling to change on the targets as well, you know.
That's great. Yeah. So for now, you could use my open source solution to alert you about the new changes, and then you could either use the change script or the DBA tools commandlets to synchronize between the instances.
Yeah.
It could be like some kind of workaround, but it would be preferable if there was some kind of built-in solution for Microsoft. Yeah.
Yeah, I agree. And I mean, until then, all the people involved in building DBA tools, they really listen to requests. So I've had a few like requests just on Twitter, and a couple of versions later they're implemented. So
yeah, they're awesome.
They're good. We have it's a great idea, but perhaps the scope is too large. Perhaps it needs to be split into functionality requests. Yeah, maybe, I don't know.
You mean in terms of like the different server level object types?
Or maybe one would be for one request would be to make it kind of HADR aware, and something else would be, you know, to split it in 2 different features. I think my experience with most, it used to be called Connect, now it's called something else, is that they're usually closed without any action, won't implement or something. Or they're not closed at all, that's even worse.
Or they don't get any attention at all.
Yeah, true.
Yeah, so it's all about the votes, I think. The more votes there are, the more attention it will get.
I've seen some requests for like a more robust transaction handling, because now it's kind of random which error will doom the transaction and which will not, and they have tons of votes, and they're closed with won't implement, or they're not. Some of them are not closed at all. So they're just remains open and nothing happens, which is, I mean, it's even worse. So, and I guess for most users, it's good enough as it is, but for people who are used to be working in Oracle or something that actually has a proper transaction handling, it makes a big difference. So, yeah.
Well, it's worth a try.
Yeah, I think Microsoft, they're focusing on new cool features, and not as much as they should on fixing the features that already exist.
Yeah, that's true. This is also why I think they didn't really invest in the MS66 feature, because it was first released very long ago, and since then, I mean, back then it wasn't very common to see high availability disaster recovery environments. It was very rare, but nowadays it becomes more and more common, especially with the always on availability groups, and Microsoft are all the time releasing new features with it, and they are very focused on that. So I would assume that if they give so much focus to availability groups, they should have a similar solution for several level objects.
Yeah,
It
I
makes
agree.
sense that it would be necessary. Yeah.
And I mean, they've kind of done it with the jobs when it comes to transactional replication. For example, if you have pooled subscriptions, then the jobs are actually failed over when you do a failover. So they have some kind of mechanism for it. It's just that it's not available to anything that we can control. It's just built into the transactional replication wormhole.
Interesting. So maybe they already have some kind of basis for this, maybe.
Yeah, so
They could use that. Yeah.
it should be exposable somehow to us as well.
That's a good point.
Yeah, I see some comments here in the chat with thanks for the informative session and nice session, and I totally agree. I don't see any more questions though. So I think maybe we should call it the day, or I don't know, go back to work or something as boring as that. I'm just gonna show a slide or two before I stop the recording, which is, there we go. First slide I want to show is this one. It has to do with SQL Friday 2021, because as it looks now, the schedule for the rest of 2020 is filled. We will have Uwe Ricken closing out the season on December 18th, and then we'll take a holiday break. But in 2021, I'm looking for new speakers or old speakers who have new sessions to give. So call for speakers is open for the first half year on sessionize.com/SQL-Friday. It's open now, and it's going to remain open until early November. And the next thing I want to show is this few community events that are also happening. So Data Weekender is going to happen on October 17th. I'm one of the organizers, so it's kind of a shameless plug on my part. But we had a lot of fun when we organized it in May, and we're doing a sequel of it on October 17th. And the call for speakers is open for that one too. You can find it if you go to dataweekender.com and just click your way to the call for speakers. So if there are any speakers still listening, just go ahead and submit both to SQL Friday and Data Weekender. And my final slide is PASS Virtual Summit. It's one of the few events these days that actually costs money. There is a lot of value in it though. So I have registered and I will attend. There are some really good pre-cons, if nothing else, that you won't get for free anywhere else either. So they're worth all the money. They're not expensive. They're not for free either, but I guess SQL Friday is the only free lunch you get anyway. So I really recommend that, both because I think it's an excellent conference. I've been to a couple of PASS summits when they were in person in Seattle, and I think this virtual one will be a good one too. But also because PASS as an organization actually depends on people going to this virtual summit. So if you have an employer that can pay for it, it's going to be good value for you, and it might keep PASS as an organization alive for another year, because they're really struggling financially. And at least for me, I have a lot in my career to thank PASS for all the SQL Saturdays and the summits and so many events and user groups that taught me a lot and brought me onto the speaker scene, and actually got me into starting my own business as well, at least in part. So that's the thing that is not, I don't have any self-interest other than that I want PASS to survive as an organization. So if you can, please attend. That's all for me. Then I want to end, of course, with thanking Eitan for coming to SQL Friday. Thanks for lending your time. I really enjoyed the session.
Thank you for having me.
I hope we will meet again, and hopefully we will go back to some kind of in-person life where we can actually shake hands and say cheers and so on. But until then, this is what we will live with.
Yeah.
So I'm
Good
gonna go
luck to
back
all of us.
Yeah. Yeah, I mean, it's going to happen eventually. There's going to be a vaccine sometime. I just hope that it won't come out to the market before it's actually safe to use it. And,
Yeah, will make things worse.
Yeah. Anyway, so thank you again. I'm going to stop the recording and go back to my paid work.
Thank you. Bye bye, everyone.
Bye.